Good evening, ma'am. I am Ananya. So today I'll be doing SJF primitive is also known as SRTF, used for creating and validate. So moving on to the next contents, I have included introduction, objectives, problem statement and experimental setup, implementation steps, code, output and comparative evaluation, test cases and critical evaluation and conclusion. Next, coming to introduction, operating system scheduling overview. We have used CPU scheduling is the backbone of the multitasking operating system, wherein multitasking processing are ready to execute the CPU scheduler, which process should run next based on the scheduling algorithm. A maximum algorithm aims to maximum CPU utilization, reduce wastage time, reduce turnaround time, responsive time, minimize switching and overhead. Coming to overview of SRTF. SRTF is also known as shortest remaining time first, which is the primitive part of SJF. So CPU can be taken away primitive at every arrival time or compare the process with least remaining burst time execute first. SRTF is the primitive version of SJF and usually provided the minimum average waiting time of all scheduling algorithms. Moving on to the objectives of this assignment, so we have designed and implemented a primitive SJF which is known as SRTF scheduler, and to visualize all content switches using Gantt chart, run and validate the scheduler using three different datasets. So we have used three different test cases to show the different forms from one set to the another set, and to compute waiting time, turnaround time and the number of content switches. So next, even to critically evaluate improvements and to write and analyze and discuss. Moving on to the problem statement and experimental setup. So the problem statement is SJF primitive. We have selected this problem statement. I have selected this problem statement to create a primitive SJF scheduler and integrate a feature to visualize content switching in a Gantt chart. It is used to correct the design or the analyze using three test cases and critically evaluate and reduce wastage of time. So coming to the experimental setup, here the programming language we have used is Python. The IDE is the online Python compiler and execution is terminal. Here we have used the data which is of three types: the process ID, arrival time and burst time. So we have three different test cases we have implemented in this topic. The case 1 is basic, the case 2 is high arrival variation, the case 3 is heavy primitive scenario. So here are the implementation steps which we have included in our assignment. So step by step process. It is used to define all the list of process with PID, arrival time and burst time. With process ID, arrival time and burst time. It is used to copy burst time into remaining time array. It is useful for start stimulating from time 0 and loop until all process finished. At every time until elect the process that also arrive. So we have arrival time, which is considered to be in the form of the greater than the burst time. It also has the smallest remaining time. If the running process changes, record a new entry in the Gantt chart. It is used to execute and elect process for one time until and decrease remaining time. So we have used the turnaround time. We have two different formulas in the shortest job algorithm primitive, which is SRTF. Though turnaround time formula is finish time minus arrival time, whereas waiting time is equal to turnaround time minus burst time. So after completing this, we have print Gantt chart and also process the table. So here we have used the complete code which is of Python. Here we have defined each and every arrival, burst time and remaining time with its time complexities, like including the remaining valuable times. Here we have included the Gantt chart and what the processor should be ahead taken. Like here we have given print process arrival time, burst time, finish time, turnaround time, and waiting time. So in the output will be getting including the Gantt chart. Moving on to the output, once we have executed this code, so the output we obtained is P1, P2, P3, P2, P1. So according to the SJF primitive version, so we have upgraded the processor units to each one of them. So in P1 we have given the arrival time, burst time. So we have found the final time and the turnaround time and waiting time using the formula. Here is the annotated Gantt chart. So in the annotated Gantt chart, we come to know the different forms of process ID we have used. So process 1, it is useful for running first, which is permitted by process 2. Next, process 2 is permitted by process 3. Process 3 shortest job, finishes immediately. So again process 2 runs and finishes its job. So last process 1 completes. In this way we have used the annotated Gantt chart for the given query. So coming to comparative evaluation, so we have the parameters. Here we have the two main factors used here. So coming to here comparative evaluation, we have three data sets, as we have used case 1 and case 2 and case 3, which is also known as three data sets. So we have taken the average waiting time, average turnaround time, content switches and remarks. So average waiting time and average turnaround time is calculated by the formula, and the remarks in the case 1 is light primitive, in the case 2 is very low waiting, and in the case 3 is heavy primitive, increases maximum time of switches in them. So here are the test cases we have used. So in the test case 1, we have taken the Gantt chart in a normal basic case. As we have said in the comparative evaluation, we have used the lighter primitive. So here after the result table is obtained, we can notice the average waiting time is 1.66 and content switches are 4. So in case 2, which is very low waiting time, as we can see the waiting time is very low, average waiting time is about 1.25, and content switches here is also present is 4. Next, moving on to last case, heavy primitive increases switching. So we can observe compared to first and second test cases, the third case test cases, the content switching is higher, like it's 6, and the average waiting time is also been bit increased, which is 3. In this type of forms the variations takes place. So coming to critical evaluation, SRTF performs best when job has different burst time, shortest task frequently arrived, and we need less average waiting time. Observation, like SRTF reduces lowest average waiting time out of all algorithm, more primitive, more content switches, small processes never wait, excellent for interactive system. So the drawbacks of the main SJF are frequently primitive can cause higher overload. So there will be more overloaded to it. So there will be cases of prediction over the burst time might get reduced. It also requires correct prediction of the burst time, more complex than first come first serve or non-primitive SJF. As we can see, non-primitive SJF is quite easier compared to primitive SJF. So coming to the output. So coming to the output of the slide, the SJF, it says that the SRTF, shortest remaining time algorithm scheduler, is the high frequency primitive scheduler algorithm that significantly reduces wasting time and turnaround time compared to first come first serve and round robin. It is the best algorithm for minimizing average waiting time because permission. It can also work well when variable arrival times and higher content switches is of trade-off. So all three data sets validate that SRTF consistently perform better, especially when short tasks frequently arrive. Based on the observation and analysis from all data sets, SRTF proves to be a powerful algorithm that balances everything with mixed, short, and a long process. Thank you.